This is lesson 5-4, medians and altitudes. We're going to start by defining what a median is. A median is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. So we already talked about midpoints. A midpoint is a point that divides a segment. So this point right here is a midpoint, and as you can see, it's dividing the left segment and the right segment, and it's telling us they're congruent. So median is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. So the vertex is up here, so it's a line drawn from the vertex to the midpoint of the opposite side. So it's just like a bisector in that it's a line that's going through the midpoint, but this line is specifically in the triangle and it's drawn from the vertex of the triangle. So it's a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. It does not have to come from the top. There's medians from each of the vertices. So over here on the left, there's a median that could be drawn from here to the midpoint of the opposite side. And over here on the right, from this vertex, there's a median that can be drawn from here to the midpoint of the opposite side. Now the centroid is the point of concurrency of the medians of a triangle. So the centroid, the centroid is the point of concurrency of the medians of a triangle. So if I was to draw all three medians in this triangle, it's actually drawn down here. Okay, DJ is a median. I can see that it's drawn to the midpoint because I'm showing that FJ is congruent to EJ. And FH is a median because I'm showing that DH is congruent to EH. EG is a median because I'm showing that DG is congruent to FG. They all meet at this point right here, point C, and that point is called a centroid. So a centroid is just a name for the point of concurrency of the medians of the triangle. They will meet at a single point. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, so there's a mathematical relationship in these lines. The medians of a triangle are concurrent at a point, so this point C right here, it's 2/3 the distance from the vertex to the midpoint of the opposite side. So the whole distance DJ, DC, from the vertex to that centroid is 2/3 of DJ, and from CJ it's 1/3. So this line DC is actually twice as big as CJ is. And right here FC, it's twice as big as CH is. So DC is 2/3 of DJ. Whatever DJ is, that whole median, DC is 2/3 of it. EC is 2/3 of EJ. So EC right here, okay, is 2/3 of EG. And FC is 2/3 of FH. So the distance from the vertex to this centroid is 2/3 of the whole median. So if, say, DC was 10, CJ winds up being 5. It's twice as big as that section right there. Okay, and then we're going to do altitudes and orthocenter. An altitude is the perpendicular segment from the vertex of a triangle to the line containing the opposite side. So it's a perpendicular segment, so it's a line drawn from the vertex of a triangle perpendicular to the opposite side. Perpendicular means it's going to be forming right angles. So the altitude is like the height of the triangle. It's a line drawn from the vertex of a triangle to the line on the opposite, it's perpendicular to the line on the opposite side. The altitude can be inside, it can be outside, or it can be on the side of a triangle. And I'll show you an example of each of them. Okay, so altitudes can be inside the triangle, outside the triangle, or it can be actually be a side of the triangle. So where I'm going to have altitudes drawn from each of the vertexes, and they're going to meet at a point, and that point has a name. It's called the orthocenter. So the orthocenter is the point of concurrency of the altitudes of a triangle. So where all three altitudes of a triangle meet, they're going to meet at a single point, and that point is called the orthocenter. The orthocenter is the point of concurrency of the altitudes of a triangle. The orthocenter, just like the altitudes, it can be inside, on the triangle, or outside the triangle. So if I have an acute triangle right here, here's an altitude, here's an altitude, here's an altitude. See how it's drawn from the vertex perpendicular to the opposite side, from the vertex perpendicular to the opposite side. If it's an acute triangle, that orthocenter will be inside the triangle. If it's a right triangle, see, vertex perpendicular to the opposite side, vertex perpendicular to the opposite side, they all meet right here, and that point is on the triangle. So for a right triangle, it's going to be on the triangle. And for an obtuse triangle, see the triangles in black right here? So for an obtuse triangle, this altitude is actually outside the triangle. And if I was drawing the altitude from the vertex, from this vertex, it's going to be right here. And then from this vertex, I just continue it to meet the other three, and you can see that they meet outside. Okay? So those are our two new words today, orthocenter and the centroid. And we'll just review all four words that you should know at this point. So these are the special segments and lines and triangles. Okay, the first one we did was the circumcenter, and the circumcenter is where the perpendicular bisectors meet. The incenter is where the angle bisectors, see how it's bisecting? The incenter is where the angle bisectors meet. The centroid is where the medians meet. And then the orthocenter is where the altitudes meet. So you can write that down. The circumcenter is where, I think I have it right here, is the perpendicular bisectors. All right, it's not clicking. So circumcenter is the perpendicular bisectors. The incenter are the angle bisectors. The centroid are the medians. So you're writing each of these down. And then the orthocenter is where the altitudes meet. Okay, so on your summary page for 5-4, if you can fill in the questions that were asked of you, write down any questions that you have, and then do the sum it up, and then we will practice all these two words tomorrow. And that's it for today.